Good morning, friends. This is my third lecture on the general organic chemistry, and today we are going to see the points to draw resonating structure. Points to draw resonating structure. In previous lecture, we saw the conditions of resonance, general conditions of resonance, general conditions of resonance, and you may remember that is the A double bond B C have either positive charge, negative charge, lone pair, free radical, or multiple bond. Means if this conjugate position, if this conjugate position, if this conjugate C position has positive charge, negative charge, lone pair, free radical, or multiple bond, and if it is in conjugation with A double bond B C, then if such type of condition is observed in any molecule, in any organic molecule, then we say that resonance is possible. Resonance is possible in such molecules. Now today we are going to see the points to draw resonating structure. Points to draw resonating structure. Now the knowledge of knowing different correct drawing the resonating structure helps to identify the electron density in the molecules. Electron density in the molecules, and once the electron density is exactly pointed out in the molecules, then it is useful to identify the final product of the molecule in that particular reaction zone. So it is very important to consider points to draw resonating structures, isn't it? Now first point for writing the resonating structure, that resonating structures are differs. Resonating structure, in short, I will write from here onwards RS. Resonating structure differs only with respect to pi electrons and their sigma bond skeleton remains same. म्हणजे याचा अर्थ काय झाला, जेवढे रेझोनेटिंग स्ट्रक्चर्स असतात त्या सगळ्या रेझोनेटिंग स्ट्रक्चरमध्ये पाय बॉन्ड्स जे असतात किंवा पाय इलेक्ट्रॉन्स जे असतात ते सेमच असतात, पण सिग्मा बॉन्ड असतात ते काय असतात, रिमेन्स सेम, कॉन्स्टंट असतात. एक्झाम्पल घेऊया. फॉर एक्झाम्पल कन्सिडर लाईक दिस. हिअर सपोज डबल बॉन्ड, हिअर डबल बॉन्ड. इफ आय गिव्ह नंबर्स 1 2 3 and 4, isn't it? If whether the resonance is possible or not in this case, just apply last lecture's concepts. A double bond B, C have double bond, means it is resonance is possible. So on resonance, if suppose the bond between A and B, pi bond, is shifted in between B and C, sorry 2 and 3rd, at the same time 3rd 4th bond is shifted on 4th carbon atom, like this it is shifted, and after resonance the structure is like this. Double bond between 2 and 3, and electron density from first carbon is moved in between 2 and 3, that's why it is positive charge, and on the fourth carbon it is negative charge. So see, if you observe these two structures, it is seen that the number of sigma bonds in first structure, and this is suppose second structure. In first structure, number of sigma bonds, if you count 1 2 3 sigma bonds, isn't it? And the number of pi bonds or pi electrons, if you count double bonds, they are pi electrons or pi bonds, 1 and 2 pi bonds are there, isn't it? If you consider in this case number of sigma bonds, yes, 1 2 and 3. Number of pi bonds, only one pi bond. There is only one pi bond. Now see the first point, resonance structures differs only with respect to pi electrons. Here 2 pi bonds are there, here 1 pi bond is there, isn't it? Okay, so this is the first point. All resonance structure differs from each other only with respect to pi electron system. Their sigma bond skeleton remains same. Second point, that is all resonating structures means in all resonating structure the position of atoms does not changes जेवढे रेझोनेटिंग स्ट्रक्चर्स असतील त्या सगळ्या रेझोनेटिंग स्ट्रक्चरमध्ये त्या ॲटम्स मॉलिक्युल्समध्ये असणाऱ्या ॲटम्सची पोझिशन आहे त्या पोझिशनमध्ये बदल होणार नाही आहे. तर हेच एक्झाम्पल जर कंटिन्यू केलं, सपोज like this, or any other example, suppose like this. Here suppose double bond or plus charge, and A double bond B C lone pair. If suppose like A double bond B C have lone pair, isn't it? And if I resonating, no, this is a 2 here, plus charge. If I resonate here, then what's here? If lone pair comes here, it comes here. Then oxygen there. Oxygen पासून double bond इथे तयार झालेला आहे, isn't it? So in this case, one positive charge, and here pi bond is shifted. Pi bond is shifted, isn't it? Now see, if you consider the number of bonds, number of atoms, if you count here from here 1, 2, 3, 4, and 5, or right from 1 to, nomenclature is not necessary here, means we are going to study in detail. Just we are considering the position of atoms. From here right side, if you count, oxygen is at the second position. Here also if you count, oxygen is at the second position. Means for during writing resonating structure, position of atom does not changes. Position of atom remains same. Position of atom remains same. This is the second point. This is the second point. Then third point as far as concerned. Third point. That is, resonating structures must follows proper Lewis structure. All resonating structure must follows, or they must be of proper Lewis structure. प्रॉपर लेविस स्ट्रक्चर असायला पाहिजे. आणि प्रॉपर लेविस स्ट्रक्चर म्हणजे काय सांगतो की सगळ्या ॲटम्सचे, त्या मॉलिक्युलमध्ये असणाऱ्या सगळ्या ॲटम्सचे ऑक्टेट जे आहेत ते ऑक्टेट सॅटिस्फाय झालं पाहिजे. म्हणजे कुठलाही ऑक्टेट इनकम्प्लीट किंवा एक्सपांड होता कामा नये, isn't it? So if you consider one example, suppose CH2 double bond CH dash NH3 plus. Here nitrogen is positive. So one more example, CH2 double bond CH dash OH2 plus, oxygen positive. And one more, CH2 double bond CH single bond FH plus, FH plus, isn't it? Now if you consider all the cases, all the three cases, number 1, number 2, and number 3. From the previous lecture knowledge, we say that in all the three cases there is a resonance is possible, isn't it? By first observation, A double bond B, C have positive charge. A double bond B, oxygen has positive charge. A double bond B, fluorine has also positive charge. Means just resonance is possible in this case. But after resonance, what is the condition? If I resonate this first, for example, suppose the double bond is shifted from here in this case, then what happens? CH2 single bond CH double bond NH3, NH3. Just by observing this, and here positive charge, and here if you consider the nitrogen, the octet of nitrogen is violated, octet rule, because in this case there are 10 electrons around the nitrogen. Why? Because if you consider double bond आहे आणि शिवाय 3 हायड्रोजन ॲटम्स आहेत, म्हणजे ह्या नायट्रोजनमध्ये लेफ्ट साईडला 2 बॉन्ड्स आहेत म्हणजे 4 इलेक्ट्रॉन्स, आणि राईट साईडला नायट्रोजन 3 इलेक्ट्रॉन्स म्हणजे 6 इलेक्ट्रॉन्स. सो दिस 4 + 6 10 electrons. So it is violated case. Means in this case also the oxygen and also fluorine, they expands their octet. So it is not possible. There must be a proper Lewis structure. Then next, that is the all resonating structures must have same number of bond pair electrons. They must have same number of bond paired electrons. They must have same number of bond paired electrons. And as they have same number of bond paired electrons, in the sense, yes, if you consider the like this positive charge, then in this case if I resonate like this, double bond positive charge. If you count number of pi bonds, then there are 2 pi electrons. Here also there are 2 pi electrons. Okay, means they have same number of electrons in both the cases, pi electron system. Then next, there is the fifth. That is, if resonating structures or conjugate position in resonating structure, if conjugate position have more than one pi bonds, isn't it? एकापेक्षा जास्त पाय बॉन्ड जर असतील म्हणजे ट्रिपल बॉन्डची पोझिशन असेल. इन दॅट केस यूज ओनली वन पाय बॉन्ड. इन दॅट केस यूज ओनली वन पाय बॉन्ड इन रेझोनन्स. रेझोनन्समध्ये एकच पाय बॉन्ड वापरायचा. फॉर एक्झाम्पल जर कन्सिडर केला केसेस, सपोज CH2 डबल बॉन्ड CH, A double bond B, and in this case if I consider not CH2, just if I take an example, there is a like this triple bond, isn't it? And here double bond, then A double bond B, C have positive charge, A double bond B, C have triple bond. Okay, and in that case if I draw the resonance structure, first after resonance what happens, double bond is shifted here, at the same time triple bond is shifted here. Means structure is like this, CH to NR double bond, आणि इथं CH 2 3 म्हणजे CH फक्त येणार, सिंगल बॉन्ड फक्त C येणार इथं ह्या पोझिशनला, ओनली C, अँड देन ट्रिपल बॉन्ड CH, ट्रिपल बॉन्ड. हे स्ट्रक्चर म्हणजे हे आहे. आणि ह्या स्ट्रक्चरमध्ये आता रेझोनन्स काढला तर A डबल बॉन्ड B C हॅव ट्रिपल बॉन्ड. मीन्स इन दिस केस ट्रिपल बॉन्ड, दिस वन पाय बॉन्ड, दिस वन पाय बॉन्ड. म्हणजेच काय सांगितलं आहे, एकापेक्षा जास्त पाय बॉन्ड असतील म्हणजेच ट्रिपल बॉन्डची कंडिशन असेल तर त्या दोन पाय बॉन्डमधला एकच पाय बॉन्ड रेझोनन्समध्ये यूज करणार. म्हणजेच हा पाय बॉन्ड इथं आला तर हा पाय बॉन्ड इकडे गेला, म्हणजे रेझोनन्स असे येणार CH2 सिंगल बॉन्ड CH डबल बॉन्ड C डबल बॉन्ड CH, and it is negative charge, and at the same time here positive charge. At the same time इथे ह्या स्ट्रक्चरमध्ये कसं येणार, लाईक दिस, डबल बॉन्ड इथं येणार, इथं पॉझिटिव्ह आणि इथं डबल बॉन्ड निगेटिव्ह, डबल बॉन्ड निगेटिव्ह. असे बोथ स्ट्रक्चर्स आर सेम, बोथ स्ट्रक्चर्स आर सेम. ठीक आहे. अँड इफ द मल्टिपल बॉन्ड्स ट्रिपल बॉन्ड इज प्रेझेंट ॲट कॉन्जुगेट पोझिशन. नाउ सिक्स्थ पॉईंट, what is the sixth point? If conjugate position have multiple bonds, if conjugate position have multiple bonds, means either double or triple bonds, multiple bond, double or triple bond, along with lone pair of electrons, along with just lone pair of, along with, see conditions like this, lone pair of electrons, free radicals, negative charge or positive charge. म्हणजे जर कॉन्जुगेट पोझिशनला, म्हणजे थोडक्यात A डबल बॉन्ड B C ही कॉन्जुगेट पोझिशन आहे, कॉन्जुगेट पोझिशन. आणि ह्या कॉन्जुगेट पोझिशनला जर डबल बॉन्ड पण आहे किंवा ट्रिपल बॉन्ड आहे, आणि डबल बॉन्ड आणि ट्रिपल बॉन्ड बरोबर ह्यातला कुठलाही केस जर इथं असेल, म्हणजे इथं लोन पेअर पण आहे, निगेटिव्ह चार्ज पण आहे, पॉझिटिव्ह चार्ज पण आहे, किंवा फ्री रॅडिकल असेल, असं जर कंडिशन असेल तर ह्यातल्या लोन पेअर, निगेटिव्ह, पॉझिटिव्ह किंवा फ्री रॅडिकलपैकी कुठलाही पॉईंट यूज न करता जस्ट वी यूज द मल्टिपल बॉन्ड जो आहे तो रेझोनन्समध्ये कन्सिडर करायचा. दॅट कॅन बी एक्सप्लेन्ड हियर. इफ बेन्झीन and here like this lone pair, so first case the example of negative charge, then if positive charge, third case if nitrogen is placed and lone pair like this, or suppose free radical. Then if you consider any case A double bond B, here A B and C, A B C, A B C, A B C. Now if you consider A double bond B C have multiple bond, at the same time negative charge on the carbon. A double bond B C multiple bond, at the same time positive charge. A double bond B C multiple bond, at the same time lone pair. A double bond B multiple bond C, at the same time lone pair. Then in that case negative charge, पॉझिटिव्ह चार्ज, लोन पेअर किंवा फ्री रॅडिकल ह्यांचा रेझोनन्समध्ये यूज न करता डायरेक्टली रेझोनन्स स्ट्रक्चर्समध्ये असं दाखवणार आणि त्या रेझोनन्स स्ट्रक्चरमध्ये एकच दाखवतो ते केस. इट इज द लाईक दिस. इट इज द रिमेन्स निगेटिव्ह चार्ज and after resonance the electrons are shifted like this. Electrons are shifted like this. So the resonance is possible without disturbing this negative, positive, lone pair or free radical, isn't it? Okay. So these are the points for the sixth point. So you would remember these some points for writing the resonating structures of different molecules. If you know the exact how to draw the resonating structure of molecules, then it is useful to in considering the stability of different resonating structures and also in deciding the reactivity of the carbocations, carbanions, etc. Okay. In next lecture we see the points to check stability of resonating structure. Okay. Thanks.